Hi everyone, we are going to do more practice with Pythagorean Theorem today. And one thing that I wanted to remind you of was the Pythagorean Triples. So these are sets of three numbers that always work with the Pythagorean Theorem and are commonly used in problems. If you recognize that one of these triples is used in a problem, you don't have to show any work. And it also works for multiples of triples. So like for the second one, if you found 10 and 24 in a triangle, that's 5 doubled and 12 doubled. So the last number must be 13 doubled, which is 26. So as long as they're in the proportion and all multiplied by the same number, that works. There is a pretty cool connection between the first number on the list and the next two numbers. There's a pattern. And if you're interested, you could see if you could try to figure that out. Let's take a look. So this first page is all about connecting Pythagorean theorem to slant heights and right triangles within 3D figures. It's really helpful for surface area and volume problems where not all the information might be given. So let's go over some vocab first. The height of a 3D shape must be perpendicular to the base. Therefore, it forms a right angle. It's usually abbreviated with an H. So the height on the cone would be this right here, and the height on the pyramid would be this right here. On the pyramid, they've marked that right angle for you, but there would also be a right angle on the height of the cone. So if it's the height, you can assume it makes a right triangle with the base. That's also called the altitude, if you've heard that term. The slant height of a 3D shape, and usually it would be if we're talking about a cone or a pyramid, is the distance from the point at the top, which is called the apex, and the base of the side of the 3D shape. And it's usually abbreviated with that cursive L or an S. So on the cone, here's the slant height. So this would be the apex, and then this would be where it meets the side of the base. And they use the cursive L there. And in the pyramid, it's the same idea. Here they've used the S, which is a lot less common, but it's there sometimes. Here's the apex of the pyramid. And then here's where it meets the side of the base. And it's always going to be right in the middle of the side too. All right, one more term is radius, which is the same definition that we learned for radius of circles. The radius is half the length of the base. In a cone, it's easy to know what the radius is because it's just the radius of the circle. But like for a pyramid, we don't really talk about radius of a square or a rectangle, but it means the same thing. It's halfway across. So here's the radius, halfway across that circle. And then for a pyramid, it's halfway across the square or the rectangle, whatever that shape is. And if you notice, these three measurements together form a right triangle. So if you know two of the measurements, you can use the Pythagorean theorem. So let's take a look at some of these problems. In problem number 1, it asks us to find the height. So different pieces might be missing in these problems. What you might like to do is draw yourself a little right triangle off to the side. It might just be easier to see everything. Here's my right angle. I can see that this side is 5. That's the radius. H, we don't know that side. And this is 13. 13 has to be our side C because it's diagonal from the right angle. And then 5 or H could be A and B. You could switch them, doesn't matter. Now you might recognize right away that this is a triple. It is. And if you recognize that, you don't have to show any work. You could just go straight to the answer. Let's pretend I didn't recognize it though. So a squared plus b squared equals c squared. I'm going to do 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. Subtracting 25 from both sides, you get b squared equals 144. Take the square root of both sides, and you get b equals 12. And the units would be centimeters. So 12 centimeters is the height. Now, if you recognize that that was a triple, you don't need any work. You can just say the answer is 12 centimeters. And it just acknowledge that everybody knows that that's a triple. But if you don't catch that it's a triple, feel free to show the work. Before you guys start the next two problems, I do want to point something out with the type of information they give you. So sometimes in a problem like number 2, they give you this. 16 is the length all the way across the base of the pyramid. But we can only use the radius, which is halfway across the pyramid. So it's not hard to find it, but that is just one extra step you need to do. You need to find half of that length across the pyramid before you can get started here. So pause the video, try 2 and 3, come back when you're ready to move on. All right, hopefully you're ready to move on. Let's take a look at this page. So this is kind of interesting, and this is a real life fact that I didn't know until I was older. It says the size of a TV screen is the length of its diagonal. And that's really how they talk about TVs when they're selling them. So like for TV A, if you were to buy this in the store, whatever this pink line is worth, that's the size of the TV. They wouldn't say it's a 40-inch TV. They wouldn't say it's a 30-inch TV. They'd say however long the diagonal is, that's the size of the TV. I'm guessing they do that because if it was 30 or 40, you'd have to like say both numbers. You'd have to specify if it's the length or the width. If it's diagonal, like everyone, I guess, has a common way of saying it. So, pause the video, see if you could find the length of that diagonal, which is how big the TV is. All right, hopefully you have found the length of that diagonal. So I see, I'm going to use this triangle. You could also use the one kind of above it. So you could use it in yellow here, or you could talk about this triangle in orange. I'm going to use the yellow one though. It'll get you the same answer. So I have my 40 inches. And then the 30 inches is going to slide across. Those are my A and B. It doesn't matter which one's which. I need to find C. Right away, I can see that this is a triple. This is a 3, 4, 5 triangle. Because here's my 3, 4, 5. If I multiply everything by 10, I will get 30, 40, and 50. Now my 30 and 40 are swapped, but it doesn't matter which place you have the A and B. So this 30 and 40 matches with this 30 and 40. Therefore, C must be 50. That's a 3, 4, 5 triangle, so 50 inches. You could have done the work with the Pythagorean theorem, but if you notice the relationship to the triple, you wouldn't have to show any of that work. So I'm going to leave B and C for you guys to do. On number 2, they ask us to find the length of the segment. And it is possible. I don't know why they bother saying if possible. If you know the distance formula, you probably have another way of solving this. But the distance formula actually comes from the Pythagorean theorem. And that's something that we're going to be talking about. What we can look at is segment AB as the hypotenuse of a right triangle. So you could draw a right triangle like this, or you could draw one above it with a hypotenuse on the bottom. Here's my right triangle. What I need to do is, maybe I'll use 2 different colors. I need to get the length of the pink side, and I need to get the length of the orange side, and then I'll have 2 sides of my right triangle. For the pink side, you just count. 1, 2, 3, 4, 5, 6. Orange side, just count. 1, 2, 3, 4, 5, 6, 7, 8. Pause the video, see if you can find the hypotenuse, which would be the length of the segment. All right, hopefully you have found the length of the segment. Now this is another triple, but I'm going to pretend I don't know that yet. 6 and 8 would be A and B. Neither of them are the hypotenuse. The hypotenuse is diagonal from the right angle, and it doesn't matter which one's A and which one's B. So I'll start with the formula. A squared plus B squared equals C squared. 6 squared plus 8 squared equals C squared. That's going to be 36 plus 64 equals C squared. 100 equals C squared. Take the square root of both sides. 10 equals C. And we would just say 10 units. Now that would be the work if you didn't recognize the triple. If you did recognize the triple, we can say that this is a 3, 4, 5 triangle, and what they've done is multiplied it by 2 to get 6, 8, and 5 times 2 is 10. You wouldn't have to show any of that work. I'm just demonstrating it to you. So either way, 10 units. Make sure you guys finish up the assignment. Thank you.